All right, so now we are on lesson 2 of polynomials, and it is addition and subtraction of polynomials. So we're going to start with the addition of polynomials, and it can actually be done in a couple different ways here. So if I want to add horizontally or take two different polynomials and add them horizontally, well, I'm going to want to say if I have one polynomial and two polynomial, let's look at the similar terms and organize them by power. So in the first example here, they have x squareds, x, and a constant term. Well, they use different highlighter colors to represent the different terms or the different ordered terms. Remember though, we can do something like different colors of organization. We could highlight them, we could underline them in different ways. Organization is really important here. So in this first example, if I add horizontally, I'm going to identify the x squared terms, which in this case I have 6x squared and 2x squared. If I add their coefficients, it's 6 plus 2, and that will combine to be 8x squareds. I can do the same thing with the x terms. I can go, I have a 10x here, a 4x in my second polynomial. If I add those two together, it's 10 plus 4, which gives me a coefficient of 14x. And then finally, I have a constant term here, no constant term in my second polynomial. Therefore, the constant term just becomes that -7. Now, a second version is, what if I took two different polynomials, say those same two polynomials, and instead now I want to add them vertically. So rather than comparing them horizontally like this, what I can do is I can put this polynomial on the top, this one on the bottom, and then I can add the like terms across the different powers here. So if I start with this one, I would add across the two rows, 6 plus 2 will give me a factor of 8. If I add my 10 plus 4, that's going to give me 14, which is out front. And then finally, if I go add -7 plus a 0, well, that's just -7. So whatever way you think organizes this better, both ways are completely correct. You're not wrong doing one or the other. Now, if we go to subtract polynomials, this is where it may be better to stack the polynomials or take one polynomial and write it over the other polynomial. Here's why. When we do subtracting polynomials, we're going to need to reverse the sign of each term we're subtracting and then add them like typical. So in order to see this, I think it's important to even just do a couple examples. We could trace it just like we did with adding for this box here. However, let's actually directly apply this here. So example 1, we are going to add the polynomials, and to add them, we're going to look at this sign here, and we need to realize, is it positive or negative? Well, in this case, it's a plus, so we're going to be adding every term, and we do not have to flip the signs of that second polynomial, or the 2x squared minus 6x plus 9. So now, if I add my coefficients, and I'm going to do this horizontally, this is equal to, I have a 1x squared plus a 2x squared, that's 1 plus 2x squared. I'm going to add this to, well, the two coefficients I have for my x terms are +4 and -6. So when I do this in the brackets here, I'm going to go 4 minus 6 x's. And then finally, I need to look at the constant terms, or the ones without variables. I have a -2 plus a +9. So in the brackets here, I would go plus -2 plus 9. Now, the reason we're doing it like this is because we're adding horizontally. We could do this vertically, but I'm going to show you horizontally for this example. So I'm adding all the coefficients. This becomes 1 plus 2 is 3x squared. Then I have 4 minus 6 in that brackets. This is going to become a -2. Therefore, it's subtract 2x. And then finally, I'm going to add -2 plus a 9. Well, that works out to +7. All right, so we've seen an addition example where we add the coefficients. Now let's go to example 2 and check this one out. What is the sign in the middle? Well, we actually see a subtraction sign. So before we do anything with this problem, I'm going to rewrite out my first bracket, 4y squared minus 2y plus 3. And now I need to distribute this negative to all the signs. If we have a negative in the middle here, it means I'm technically doing -1 times everything in the brackets. So let's flip all the signs. This becomes a positive, and I have -3y squared. A negative times a +5y is -5y. And finally, a negative times a negative 2 is positive 2. Now I can add them like normal. I've taken my subtraction sign, distributed it to all three. Once I distribute it to all three, I can change it to a plus and we can add these like normal. So now I have, in this case, this is equal to 4 minus 3 y squareds. Then I look at my two y terms. I have a negative 2y and a negative 5y. I'm going to add those coefficients together. Negative 2 minus 5y. And then finally, I want to look at my constant terms. I have a 3, I have a 2. They're being added together. This is going to be 3 plus 2 on the outside. All right, so now I simplify this and go 4 minus 3 is 1y squared. We don't even really need to write the 1, but I'm going to put it in there. We have negative 2 minus 5. That's a negative 7y. And then finally, 3 plus 2 is a positive 5. There we go. All right. What may help you in both of these examples that we didn't do is when you get to your step of adding and you know you're adding or subtracting with these, identify the x squareds with one color or one different way of organizing them. So whether that's a color, a highlighter, an underline of some type, I'm going to put my x's with one color, and then I'm going to put my constants with one color. And so when I go back, I can say my yellows add together, my greens add together, and then finally my blues add together. Let's go over the next example, the one where we subtracted. We changed every sign, so we took the subtraction and distributed. When we distributed, we had a couple different terms here. We had y squareds, we had y's, and we had plus 3's and a negative 2, which were our constants. When they came together, our yellows, which were the y squareds, came together. Their coefficients were added. We added the y term coefficients, and finally, we added the constant terms together. So this is why it's really important to organize by color or some organizational method where we're able to visualize which coefficients should be coming together based on the order of the term. All right, let's try that organization technique on 2 examples here, and then you'll get to practice these on your own. So if I have a subtraction statement, I immediately see this subtraction and realize I have to distribute that negative. When I distribute this negative, it's equal to 6a squared minus ab plus 4 bracket. I can now change this to a positive and distribute the negative. Negative 7a squared minus 4ab plus 2. All the signs flip on the interior. Now I can use my highlighter and determine I have a certain amount of a squareds. I have a certain amount of ab's. In this case, the coefficient on that AB is 1. If it's not written, your coefficient is 1. And then finally, on my last one, my constant terms, I have these two. And now I can put this all together. This is equal to 6 minus 7 a squareds. Negative AB or negative 1AB minus a 4AB. This is negative 1 minus 4 ABs. And then finally, I have the constants of 4 plus 2. This will simplify to 6 minus 7 is negative a squared. Negative 1 minus 4 is a negative 5 AB. And finally, 4 plus 2, that's a positive 6. So there's our simplified statement. All right, one more example here. I now have 3 different polynomials all coming together. I was dealing with 2 polynomials in the last view. These ones, I have 1 polynomial, 2 polynomial, 3 polynomials coming together. I need to look at this and say, I have a positive here, so no signs will change on the interior. I have a negative here, so all the signs need to change on the interior. So let's write out our new statement. This is equal to the 2xy will stay the same, plus the 3x minus 2y will stay the same. Now I need to do plus and change all the signs in this interior with the negative attached. This one becomes negative 5x. A negative times a negative is plus 5y, or the sign changes. And finally, a positive becomes a negative 2y squared bracket. Now I can organize this all by constants, squareds, and x terms. If I look across this, I have 1x term, 2x terms, 3x terms. If I look across for my y's, I have 1y term, 2y terms, and 3y terms. And then finally, I only have a y squared here. So when I piece this all together for my answer, it's equal to, I'm going to take all my x coefficients, 2 plus 3 minus 5, and put x on the outside. I'm going to add this to, my coefficients on my y's are 1 minus 2 plus 5 y's. And then finally, I have the last piece, which was that negative 2y squared. There was only one of those, so I don't do any more there. And so now my simplified statement becomes, well, we have 0 x's, and then when I look at my y's, I have 1 minus 2, which is negative 1, plus 5 is 4 y's. And then there's only one y squared, and that's our negative 2 y squared. So there's our final solution. All right, now it's the check your understanding section. I want you to check these out.